Hi, welcome to IBM Cloud Certification Series. Today we are going to talk about Messaging in Cloud, Section 4.2. So the objectives for this objectives for this presentation are to understand the use cases and benefits of MQ-Lite messaging and the tooling available in Bluemix for MQ-Lite service, and different types of messaging models that can be implemented in MQ-Lite. Another key model pattern that MQ-Lite offers, which is a worker offload pattern to build an application and get an optimal responsiveness. That we're going to talk about that too. At the end, we'll talk about the languages and languages API and delivery assurance models supported by MQ-Lite. Going on to the next slide. So before going on to what is MQ-Lite and what does it do and the concepts of it, let's talk about some basic terminology involved in messaging. So first, if you're looking at the diagram on the top, we're looking at the messaging. What is messaging? Messaging is a technology that enables high-speed asynchronous program-to-program communications with reliable delivery. In this context, programs will communicate by sending packets of data called messages to each other. So if you're going to look into the diagram, on the left-hand side there is a sender and a producer, and there's a queue or a topic, and at the end there is a receiver or a consumer. So a sender sends a message to a queue or a topic, and that same message can be subscribed or received by the consumer. What is the topic actually in this scenario? A topic is a channel that through which users subscribe to receive specific messages from a producer. In the publish and subscribe messaging models, basically this is mostly used in JMS messaging. Similarly, what is a queue? A queue is a channel through which all users pull the messages they want to receive using a P2P point-to-point model, instead of automatically receiving messages on a particular topic. The producer submits a message to the queue, and the receivers or recipients can browse to the queue and decide which message they wish to receive. That's a queue. So if you're going to look at what is the definition of a sender or a producer, a sender is a program that sends a message by writing the message to a channel or a queue. A receiver or consumer is a program that receives a message. There are two types of messaging models in the messaging world. One is point-to-point, and the other one is publish and subscribe. Let's go to the next slide and see what is the data center, what is the trend in the cloud architecture now in the current present world. So there's the data center architecture and there's a cloud-centric architecture. The left side of the diagram shows you how a data center architecture is designed. Basically, it's on the client side, and everything is the business logic everything is on-premise on the data center. So which helps. There are certain concepts that are written at the bottom, like test, deploy, and operation as a whole. All these are available for an application to be deployed and managed locally. So whereas what happens what is a cloud-centric architecture? Basically, we are trying to simplify and make sure that the cloud-centric architecture is more feasible, and it helps the developers use their own languages, like mainly defining their application or services in their own language, basically using their microservices and data. Each service can have its own data residing anywhere on cloud or on-premise too. So the cloud-centric architecture probably also gives you a on-premise service scalability that is automatically needed for the application. So there's no need to manually do any sort of scaling or anything. So, and there are some small empowered DevOps team that takes care of this microservice architecture if you're going and looking at it in the cloud-centric world. So implement all your services, microservices, and have the rest REST and lightweight asynchronous messaging implemented in those services, that will be a great view of looking at the trends in the cloud architecture. So those are the two key differences when you're talking about data center, which is tied to more of one specific business logic data, and the application are tied to one specific center, whereas the cloud architecture is more simplified, that supports polyglot language inputs, and it has service scalability, which is automatically configurable, and all the DevOps services can be very efficiently used. Those are the key advantages when you're defining the cloud-centric architecture. And now let's go to the next slide and see what is MQ-Lite service. I'm just trying to give an introduction of the MQ-Lite service here. The picture itself clearly shows you, if you go to a dashboard or in the catalog of Bluemix, as soon as you get your login, there's an MQ-Lite button that is being defined. There are multiple plans that are available. You have standard enterprise plans, which you can pick and select your app to use to publish your messages or subscribe your messages. So MQ-Lite is designed to allow applications to exchange discrete pieces of information in the form of messages. MQ-Lite mainly removes much of complexity of TCP/IP networking and provides higher level set of abstractions with which you can build your applications. The pros mainly of this MQ-Lite service or the service in Bluemix is to help the developers to make responsive applications that can scale very easily. And there are also open APIs crafted to feel in a natural way for a growing range of popular languages. Tooling that makes modular app development very easy is one of the key features that will be available in this MQ-Lite service in Bluemix. Let's go to the next slide. So what are the sample use cases that are available that people use for? So as we said, worker offload pattern is one of the key use cases we see in this world, in the use case and in the industry, for which the MQ-Lite is used. Mainly what this does is it takes the intensive work, offload the application with the distributed worker process, and through which the asynchronous messaging is performed. So what does it offer? Basically, it offers a lot of scalability, and it's one of the biggest use cases, and this pattern supports one of the biggest use cases that are available, mainly for processing images or videos, performing text analytics, etc. So the next type of use case is event-driven, so which can take more actions when something interesting happens. For example, you can have email logs and updated dashboards when an event finishes. That can be updated and it can be shown on the screen immediately. Similarly, the videos upload when they're finished. When you upload a video to any of these sites, basically that is one of the types of event-driven models that can be used using MQ-Lite. So we're going to walk through a couple of more use cases in this. Mainly, the other use case is delayed processing. So in this use case, the delayed processing, things that need to happen at some point in the future, is one of the key tasks. Basically, you can schedule a task at a specific point of the time and execute a detailed report when your app is running in low utilization. Basically, if your app is not having much processes that are going on, you can run your scheduled reports at that time by using this messaging model. Similarly, you can run the end day-to-day summary for your website utilization or something, which will help your organization generate reports. So the third one is the third-party integration. This third-party integration is mainly tied to the responsiveness of the app. It ensures that the applications remain responsive when the third-party system is not available, and as it's an asynchronous messaging model, you'll get the response, and the processing happens at the end later once the system comes back up. So the main key use cases in this scenario are updating a CRM system, or just make sure if there is a book appointment that you need to update. Basically, this is one of the messaging systems that can be used in that scenario too. Now, as we talked about the use cases, let's go into the next slide of what is the tooling that is available in MQLite. When I say tooling, basically, if you're looking at the screen right now, there are numbers from 1 to 10, which gives you an overview of if you're looking at it from the left-hand side. There are different types of numbers there. So the number 1 is the link that shows you that shows you all the messages in a tab, and you can go and click on the documentation tab, which lets you take to the documentation. And number 2 shows you the number of clients that are connected. When you're sending the messages, you can be a producer or consumer or a sender or receiver. It's the same concept, but it'll show you how many clients are connected, who are receiving the message, who are sending the messages. So the number 3, which shows you the history of the messages that are being received in last minute or so. Number 4 talks about the user and password and the security of who are connected and what are the usernames that are being used. That's the number 4 thing for this MQLite service. Number 5 is talking about a sending section. If you're looking at it, it shows you the number of messages sent by the sender. That's what is shown there. Number 6 talks about you can filter on a specific client or a specific receiver. Number 7 talks about there can be multiple patterns or topic patterns that can be published through a sender or a receiver. So you can select a specific pattern. If you are MQ, you can select the pattern and look at the number of messages that are coming through from a specific pattern. Number 8 is going to talk about the receiver who's having what are the number of messages received by the receiver. Number 9 is going to talk about specifically for each client what is the topic that has been subscribed and what is the client name. Number 10 shows you whether you want to stop the processing or you want to process it in the messaging is what is number 10. The two icons, one is for pause and one is for executing. So you can see clearly that one. Number 11 shows you whether it's processed successfully or it's errored out, and the details of that can also be seen there. Number 12 talks about the messages that are received. Similarly, what are sent based on the topic. From the client side, how many messages are received is what is shown in number 12. Number 13 tells you a description of the patterns and the messages received by a particular person, and it also talks about the sharing ID that is described there. If a client is using a sharing ID to subscribe for a message, it shows you that one too. That's the basic tooling which is available in the MQLite user interface, which will give you a clear idea of whether your messages are getting processed. Let's go to the next slide. We are going to talk about the messaging models here. So there are various messaging models that are supported by MQLite here in this. If you're looking at it, this is just a simple messaging model where a sender application sends a message to a topic address or a space, and I'm just in this scenario, a topic is /test.a that has been an application is going to send a message called hello and world to a topic called test and a /test/a. The next slide shows you that's the sender side of it. So there is a receiver side of it where a subscriber or a consumer can subscribe to that topic using a pattern and subscribe to that destination, and he receives that message. So this is a simple model that is used across by MQLite, saying, hey, when you send a message, if you subscribe to that topic, you're going to receive that. This is a simple send and receive model that most of the people use in the industry. So here is the publish and subscribe model that we just talked about in the beginning based on the messaging concept. What we're trying to do here is we are trying to send an application, send a message to a send messages to a topic, and they can be sent to multiple destinations, and multiple clients can consume the messages. So this is a general pub/sub model that can be implemented in MQLite service in Bluemix. So this is the persistent destination concept, where there's one of the key concepts where, let's say, when an endpoint is down and when you want to update the status of your tweet or logs or whatever. When your endpoint is down, you want to send a message to the endpoint and it's down. What you can do is you can use this asynchronous messaging model. You can use this asynchronous messaging model that shows a sender application that publishes a message to a topic address or a space, and it will wait till the consumer will receive the message once the consumer is up. And the message is persisted in the destination layer, and the destination, the pattern is the same as what has been published by the sender application that needs to be used as soon as the consumer comes up. End application consumer comes up. There's a different type of model called sharing, which is supported by MQLite. So where there'll be a sharing ID as well as a pattern that an application can use. So what happens is, in this case, a sender application sends hello world, and a sharing ID can be used by two clients or two consumer applications. Whenever a sender application publishes a message, a piece of the message can be received by client 2 and client 3 in this scenario based on the sharing ID and the destination pattern that they are subscribing to. So this is one of the key patterns which is also implemented in the messaging world. So here we are going to talk about, this slide talks about a different messaging model called client takeover. So one of the use cases in this scenario, or let's say that the client is the consumer, when a sender application sends a message and the end user client doesn't come up in a particular time, there can be another similar backup application that can be subscribing to the same pattern of the destination topic address space and can receive the same message. This is called a client takeover pattern, and then you can use this messaging model in case your original client doesn't come up herself. As we talked, one of the key advantages of using this MQLite service is the worker offload pattern that can be implemented using the service. So here in this diagram, we are going to just talk about what a worker offload pattern would look like. So MQLite can be used to improve the level of responsiveness that a user experiences when interacting with an application by offloading the work from application's main event loop. A key factor that determines the responsiveness of the web application is the amount of time that a web server takes to process the HTTP request and send a response. So a web server needs to perform a CPU-intensive or a high-latency processing before it can respond to a request. Then the number of requests that the server can process can be reduced. This can lead to a situation where the server can no longer keep up with the rate at which the new requests arrive, and the web applications become unusable. The processing that is carried out as of a request can sometimes be time-consuming, but still not affect the response sent to the user. So that's what is shown in application 1, where it takes 5 seconds because it waits for the load to be processed at the end, and it's a call that takes 5 seconds. You can see on the right-hand side application 2. In this case, MQLite is designed in such a way this can help to simplify this task of offloading the work from the parts of an application that respond to user input. In the context of a web application, this could mean using MQLite to offload the processing from code responsible for responding to HTTP requests. To illustrate how MQLite can be used in this scenario, this model takes you through the process of building two applications. The first application performs all its processing in line. Similarly, in application 1, the application 2 comprises two components that make use of MQLite to offload work from the component that responds to the user request. When you say offload, it's offloading the work to another component that can asynchronously process the request. So that is the worker offload pattern that is being implemented using MQLite. So what are the types of messages here that are supported by MQLite? Mainly the payload can either be text or binary, and the content type used by most of the clients in this scenario is mostly JSON. And you can also have a configuration that you can set on each message or the time to live for each message. What are the messaging delivery models or delivery assurance models that are there? So one of the key concepts of delivery assurance models for MQLite are the level of message delivery assurance that is handled by QoS, which is termed and used by MQLite to describe the amount of processing that takes place to ensure that a message is transferred between the client and the server. MQLite supports two qualities of service, basically. If you're looking at the slide, one is at most once delivery, which means a message will usually be transferred once. However, situations may arise when a message will never reach a recipient. At least once delivery model, a message will usually be transferred once. However, the situations may arise when a message is transferred or duplicated more than once. At least one copy of a message will be transferred to a recipient. So that is QoS 1. Every time a message is sent from the client to the MQLite server or received by the client from the server, it is transported using one of those two qualities of service. So you can specify the qualities of service by using one of the calls that is being published by the APIs of MQLite, client.send or client.subscribe method calls. So you can also acknowledge and reject the messages if you don't like using the console, and you can take over the control of the acknowledged messages that need to be delivered and link the credit to it. And the last, MQLite API language and support. So here this slide talks more about the languages that are supported by by MQLite. Ruby, Python, Java, Node.js, and there are other things too. And mainly the other key piece of this is AMQP support. IBM MQLite API is based on Oasis standard AMQP version 1 wire protocol. AMQP is used to receive, queue, core, route, and deliver the messages. And what are the main benefits of AMQP? As we're talking a lot of things about this, it's open standard and it's a wire protocol. The first one is that, and it's built on a standardized using a standardized open source model. It's compatible with any open source AMQP client, and it's very reliable, secure, and interoperable by using interoperable. Open source wire protocol, as you can see, it says it delivers drivers for. The community itself has facilitated drivers for many languages and frameworks, and it is used by implementing the messaging models in different languages. Here are the bookmarks that you can go and read through if you want to go get more familiarized with MQLite Bluemix. Thank you and have a wonderful day.